We'll get started here in a minute or so. If you would like to go get a drink or something to eat and come back, go to the restroom, that's fine. We'll start in about a minute or so. We'll be starting here pretty soon.
Yeah.
Hey,
Mr. Investing,
yes.
I have a question for you.
Yeah,
Did you get my email with the assignments that I did Tuesday?
I've gotten lots of emails. Can you remind me a little bit? Because I don't recall off the top of my head.
What was that called? The the
The Fantastic Lab?
yeah, the Fantastic Lab. Did you get that from me? Because I sent you an email.
I will look here in a second and let you all know. In fact, that's one of the things I'm going to do, the very first thing. I have one person on here. It's just a number for me, 1002585. I need you to either turn on your video, your camera, so I can see who you are, or I need you to change your name from a number to an actual name so I know who you are. Doing that for attendance purposes. So you need to do that real soon or I'm going to have to kick you out. So I need to know who everybody is. Again, that's the one that says 1002585. Alrighty. All right, so we're going to go ahead and get started. I'm going to share with you my desktop. Okay. Wait a second. I think somebody wanted in. Let me. There we go. All right, now I'm going to share my desktop. Okay, so I'm going to look at exactly what it is we're doing today. Oops, sorry, wrong day. Wednesday, Thursday, here we are. If you remember, we came up with an equation, a mathematical model for the lab, the Fantastic Lab, and that was F net equals MA. We're just going to practice that today. But before we do that, I need to make sure that I get from you your Fantastic Lab. Some of you have already turned it in. Let me let you know who that is, so you know. Seems like this thing's always in the wrong spot. Okay, let's see. No, sorry, wrong day. So I have these people's. I'm hoping that you can see that. I have Shane's, I have Ryan's, I have Eric's, I have Trey's, Alita's, and I have Sophia's. So those people are good already. I have theirs, but if you don't see your name up here, that means you haven't turned in the Fantastic Lab that we were whiteboarding the other day. So if you're like, I don't remember, I mean, I understand you might forget. So let's see if I can click on one of these. here, and you can see, for instance, here's Shane. You remember we whiteboarded this? We kind of did it together. So all you have to do is kind of touch it up, finish it up, and send me a link to yours. And that's all you have to do. I haven't graded them yet. I'm just putting them here. I'll get to them probably this weekend. All right. So Eric, I think I took care of your question then, right?
Yep.
Okay.
All right, that's good.
Okay. So, and let me go back to the calendar. So that's done. So people know they have to turn those in if you didn't see their name up there. And we're going to be whiteboarding worksheet 3. So what I want you to do here in a second, you don't need to do it right now, but you're going to click, you're going to go to the Canvas calendar, you're going to click on this thing, it says here, and you'll see 2 files in here. As soon as it opens up, it'll say period 6 or period 1. Of course, you guys are period 6. And you'll see your name on here. So let's say you're Alan, you'll click on here, and there's a whole bunch of different whiteboards. You do not have to do every one of these. We're going to do them together. The first one we're going to be doing is this one here, in fact. Problem number 1, we're going to be whiteboarding this, okay? But before we do that, I kind of want to talk about this a little bit. So let me go back a little bit further back. All right, so this is the one we're going to be whiteboarding here in a second. And what we're using is we're using this new equation we found from lab. I'm going to circle it up here so that you guys are able to kind of concentrate on it. This is the lab. This is the equation we found in lab. Let me see if I can change that color to red, a little thicker. All right, so we're going to practice that. But before we practice that, I kind of want to practice some other stuff that we're already pretty good at. So over here is what you're going to be doing. You're going to sketch a picture. So you have to read through it. Okay, it says there's this car. Whenever I read through a problem, I'm actually skipping the numbers. So I don't even really look at the numbers. I ignore them. So it says there's this cart on this frictionless track and it's being pulled. And it just wants to know what the acceleration is. So when I sketch my picture, I kind of do the mental image I have. I imagine, I don't know, a little car, a little truck or some kids pulling. So I'm going to kind of sketch a picture of that. Once I have my picture drawn, then I'm going to do the next thing. It says, read through the problem, figure out if it's balanced or not. Well, your hint here is, let's see if I can make another one of these little circles. Your hint here is it says it accelerates. That should help you figure out if it's going to be balanced or not. Then the third thing you're doing is you're going to be drawing a force diagram. You know, that's where you're drawing like a dot with arrows and stuff on it, and you're labeling the forces. And then finally, you're going to solve it by using this equation, okay? So the way we're going to do this, the game plan is you are going to click on this link and go to that problem, number 1, and I'm going to give you like 5 minutes to work on it, okay? And then I'm going to solve it myself. So I'm not asking you to necessarily have the right answer. I want you to just try. And then in 5 minutes, I'll show you how to do it, okay? So why don't you go ahead and work for 5 minutes?
For me, when I clicked on that, it's blank after 6, period 6 color.
So you clicked on this link, you clicked on period 6, and you don't see anything?
Yeah, there's nothing there.
Okay, that happened to me earlier today. I don't know if it's all the traffic on the internet. Why don't you hit the refresh button up here and see if that does anything?
All right.
And that worked for me earlier. Okay, so why don't people go ahead and try hitting that link and go into your folder and working on problem 1, okay? Give you about 5 minutes, okay? So go ahead. I'm going to stop sharing for a little bit.
Which copy did you click on?
Is that Shane?
That was me, Eric.
Eric, would you ask me, Eric?
Which copy did you click on? Because there's a lot of things to click on here.
Okay, Eric,
Or does it
Eric,
matter?
at the bottom of your screen, there should be a little share button. Do you see that green share button? Can you move your cursor, go to the shade down at the bottom of the screen?
Yeah.
Hit the share so I can see your screen, and then hit the blue share button so I can see your screen.
There we go.
Okay, give me a second. Okay, so then Eric, can you scroll down? Yeah, actually that first one there, it says copy of number 1. Yeah, that one right there. So click on that.
All right. So how do we start drawing once we
Oh,
do?
you know what? I'm going to take Sharon away from you for a second. And then I'm going to show you how to do that. All right, so yeah, that was a good question. How to share, how to draw on here. So let me show you how to draw. Up here in the upper left, can you guys see my screen? In the upper left is a whole bunch of different tools. So let's say I'm going to draw a truck on a road or something. So let me first draw the ground maybe. So there's my ground. And then I can draw my truck or something or whatever. Mine's going to be kind of a boring truck. It's just going to be, you know, maybe black, and I'm not even going to put wheels on it, I don't think, because I want to save time. So that's how you kind of draw. Does that work?
Yeah. Okay.
All right, so play a little bit for a little bit, okay?
Can you still see my screen?
No, I can't.
Okay.
So again, I'm going to show you in a second. Just do the best you can. All right, so I'm going to go ahead and take control again and show you guys. Sorry, I had to take care of some email there. Somebody was trying to get in, was having a hard time. All right, so the first thing I'm going to do is kind of sketch a picture. I think maybe I'm going to draw. I'm imagining some kid pulling this with maybe a string. So I'm going to draw kind of a string that's being pulled that way. And so I've done number 1. Number 2 says read the problem, figure out if it's balanced or not. Can you guys go ahead and unmute yourself and tell me, is it balanced or not? What do you guys think? It says it's accelerating. So balanced or unbalanced?
Unbalanced.
Yeah, unbalanced. Yeah, perfect.
Unbalanced.
Nice. I'm going to go ahead and draw a force diagram now. So I could draw it right on my picture, but I think what I'm going to do is kind of draw off to the side so it's easier for you guys to see. All right, so I'm going to go ahead and draw in my weight force, which will go straight down. There's going to be a normal force that's straight up. It's the same size. There's this force that's kind of forward that the kid's pulling. And I think that's it because it says it's frictionless. Now I need to label these. So this force down here would be the force of gravity. This force up here would be the normal force. So force of normal. And this force here would be like a pull force or something. Force, a pull. Okay, so we've taken care of 1, 2, and 3. That should have been kind of a review. might be hard because this is kind of new, trying to figure out how to draw and stuff on here. But I think that should kind of make sense. Okay, the next part is solving. Okay, so we only have two equations up here, and that's what we're going to use to solve. Well, one of the equations is for gravity. We've done that one already, so let's practice that as well. The force of gravity is equal to the mass times 10, and it says in the problem that the mass is 2 kilograms. So that's going to be 2 times 10, and I get out my handy dandy calculator, and I do 2 times 10, which is what? Somebody tell me. 2 times 10?
20.
20. Okay, 20. Thank you. All right, so 20. Got that answer. That means the normal force up here, since it's balanced with the weight, that must also be 20. Okay, finally. Now I need to figure out what the, oh, wait a second. It says it's being pulled with a force of 3 newtons. So I actually know the pull force too. Pull force. The pull force is 3. So now I need to find the acceleration. Okay, so that means I'm going to use that new model we just found the other day. So I'm going to do the work over here on the left. F net, it's not really just F, it's F net is equal to MA. You might not have heard the word net before, but sometimes, like recently, or maybe still, your parents are going to be figuring out their taxes. They have to figure out what their net income is, which means they add up all their income and they have to subtract out everything that's going out. Net force is kind of the same thing. I have to look at what my total force is. Well, notice the gravity force and the normal force, they balance because they're going in opposite directions. They cancel. That means there's only one force. And so that means the net force must be 3. So the net force is 3. We know what the mass is. The mass is 2. And I have to figure out the acceleration. So we need to solve this mathematical problem. 3 equals 2a. Can you guys go ahead and get out your calculator and solve it? Calculate what a is.
One?
I don't think it's 1. Let's see. How would you solve?
I was solving that like a normal algebra problem, like just subtracting 2 and both
Oh,
sides.
it's not, but it's not subtraction because it says 2 times a.
Oh.
So how would you get rid of the 2? You don't want to subtract it. What do you have to do? Anybody? So the way I have to hear you is you have to turn on your microphone, unmute yourself.
Multiply.
Well, it says multiply now, so I have to undo that. So I have to divide. So what's 3 divided by 2?
1.5.
1.5.
There you go, 1.5. So the answer is 1.5 meters per second. That's the acceleration. Okay. So any questions on that one?
I do. I have one.
Okay.
Where'd you get the 3 again?
It says right up here in the problem that the kid is pulling with a force of 3 newtons.
Oh, okay. Okay. Just all plugging in, basically.
Yeah, basically. All right, so now the next one we're going to be doing looks like it says number 2 here. So that's the one we're going to be doing. And so it says that we have this SUV, it's kind of like a truck, and it's accelerating. And it says that there's some kind of resistant force on it. So maybe like friction or drag or something. And it wants to know how much force is being applied to make it accelerate. So kind of pushing it forward. So what you need to do is you need to sketch a picture first, read through the problem and figure out, is it balanced or not? And your hint is that it says accelerate here. Then draw a force diagram and then solve it. Okay, so I'm going to give you about 5 minutes to go ahead and start working on that. All right, so I'm going to stop sharing for a second. So go ahead and work on it. Does anybody want a little bit more time? You don't have to have it done. I just want you to start trying because I'm going to show you how to do it again. Okay, I'm going to stop you. I know you're probably not done because it's hard just learning how to draw and stuff, but I'm going to show you how to what the real answer or what the right answer is, and you could just see if it kind of makes sense to you. All right, so let me share my screen again with you. All right, so I went ahead. I haven't finished the whole problem, but what I've done is I've drawn a picture. So I know it's my lame truck here. There's my lame SUV, and it's accelerating. And I've drawn a force diagram over here. There's 4 forces. There's a normal force upward. There's a gravity force downward. There's a traction force. I call it traction. You could call it a push force or whatever from the road that's kind of forward. And it says there's some kind of resisting force. So I went ahead and drew it in there, and I call it drag. You can call it friction, whatever. Doesn't really matter. Okay, now it tells you, let me draw a picture here. Circle, sorry. It says that the mass of the truck is 2,000 kilograms. So let me draw this, make it red, a little thicker, so you can concentrate on it. So it says the mass is 2,000 kilograms. That means I can go ahead and find out what the gravity force is, because gravity is equal to m times 10. And so I could plug into the m is 2,000. So 2,000 times 10 would be equal to 20,000, I think. Does that make sense? Yeah, okay. It balances, the gravity force balances out the normal force. So that means the normal force must also be 20,000. Does that make sense too, hopefully? Yeah, okay. All right, then it says, I'm going to move the circle here. It says the resisting force is 1,500. So that's my drag force, or you could call it friction, whatever you want to call it, but it's equal to 1,500. Okay. So the problem wants me to figure out how much this force forward is. I'm calling it traction. You could have called it a push or whatever. Okay. Well, in order to figure that out, I kind of need to find out what the net force is. F net equals MA. So that's the next thing I need to do. So over here, I'm going to write F net equals M times A. It tells me again what the mass is. The mass is 2,000 kilograms. So 2,000 times, it also tells me what the acceleration is. It says the acceleration is 3. So it's going to be 2,000 times 3. So can somebody on the calculator figure out what that is for me? 2,000 times 3?
6,000.
6,000, thank you. 6,000. Okay, so stop right there. Any questions on any of that? Is everything all good there? All good? Yeah,
Yep.
okay. Now, here's the problem. A lot of times students will think, oh, okay, 6,000, that must be my answer. Well, no. Really, if you look at the force diagram, the traction force has got to be bigger than this drag force. In fact, how much bigger is it? Well, it's 6,000 bigger. So if I want to figure out what the traction is, I have to add 6,000 plus the drag force. So that means what I'm calling traction, force of traction, is going to be equal to the 6,000, like a lot of us thought. But it's going to also be a little bit bigger than that. It's going to be equal to the drag force too, 1,500. Because again, remember, net means total, and the drag is subtracting away from the traction. So that means the traction has got to be even bigger than 6,000. So on the calculator, can somebody please add for me what 6,000 plus 1,500 is?
7,500.
7,500. Thank you. That's my answer. That's it. There we go. Any questions? Let's see. This has been going on for about 26 minutes, so I kind of want to finish up pretty soon. I don't want to really take much more than a half an hour. All right, so the next one you guys are going to be looking at, that was problem number 2 we just did. I would like you to look at number 3. Number 3 looks very similar to number 2, but now it says it goes at a constant speed. So let's see if I can highlight that for you. It says constant speed there. And that's kind of important, okay? Because it's going to help you figure out if it's balanced or not and then solve it. So why don't you take about 5 minutes and go ahead and solve it, and then I'll show you how to do it. So I'm going to stop sharing for a second, okay? Go ahead and try it for a little bit. Okay, I know you guys are still working, but again, I don't want this meeting to go much over half an hour, okay? So, um, by the way, the rest of this worksheet, you're not doing by yourself. No, it's just like class, we're whiteboarding, okay? So if you want to, you can, but I'd really rather you just wait until Monday. We're gonna do another one of these Zoom meetings, not Monday, sorry, Tuesday. This block schedule messes me up. So our next Zoom meeting is gonna be on Tuesday, same time, 9:20, okay? And we'll pick up right where we left off at, okay? So let me go ahead and start sharing so you can see how I solve the problem, okay? All right, so I haven't got too far. All I've done is drawn picture. So this is my truck again. Now it's moving at constant speed, so it's not accelerating, okay? Notice my force diagram. Hopefully now it looks balanced, I hope anyway. Hopefully the traction force here looks about the same size as the drag force, and the gravity is the same size as the normal force, okay? It says again that the mass is 2,000 kilograms. So again, I can figure out what the weight is. It's going to be 2,000 times 10, which we already did that in the last problem. So we already know that one. That's 20,000. That means the normal is also 20,000. This problem's a little bit different because it's going at a constant speed. It says that the resistant force, the drag, now is bigger, which you can see on my picture it is. It's 2,500 newtons now. So this is equal to 2,500 newtons. It wants to know for this problem how much force is applied by the ground. In other words, it wants to know what this traction force is. Well, guess what? I don't even have to do F net equals MA because it's not accelerating. If this is balanced, how much traction force would there be? How many newtons? Look at my force diagram. See how the traction is being balanced by the drag? So how much traction would there be?
25,000?
2,500, right, that's
Oh,
it.
okay.
2,500 newtons, that's it, that's the answer. If I can type it in here, equals 2,500, that's it. Good. So that's all we're doing today. Don't leave yet because I want to tell you what you still need to do. Okay, actually, you guys don't need to do it because you're here. But I want you to stay so I can get attendance just to make sure. Okay, so you guys don't have to worry about this. Since you're here, this is your reward for coming and showing up. You don't have to do this SWIC. You get full credit for it, okay? But everybody's not here. That means they're going to be watching this video. They're going to have to do this SWIC here. But it's not that hard. Don't feel sorry for them, assuming they watch the video of this. It's really asking questions about these problems we whiteboarded 1, 2, and 3, or how to do them, make sure you know how to do them, kind of thing. So really the only work you have to do is make sure your fantastic labs turn in. I saw Haley sent me hers, I think, just now. So I think everybody, Zakira, I don't think I have yours, so make sure I get yours. I think I have everybody else's that's here in the meeting though. That's it. Then I hope you guys have a nice weekend. Are you guys all doing pretty good? Didn't get time to talk about that. Are you guys doing okay?
Yeah, I'm good.
Good.
I've been doing good lately. Yesterday took a lot longer than it should have for me. Schoolwork was just a little bit more tedious.
Oh,
Because I had two Zoom meetings plus a lot of assignments. So yeah, it took a
Oh.
while,
well,
but I got it done.
hopefully today will be better, and then of course Friday. Oh, that's another thing. Not that anybody necessarily has any questions, but I will make myself available Friday, tomorrow, even though it's really Good Friday. You know, if you have any questions, just send me an email. All right. Well, that's it. Thanks for coming. See you guys later. Bye.
Yeah. See ya.
Bye.
Bye.